can see the benefits. I think I want to definitely try to make more of my own t-shirts. This seems pretty easy.
Yeah, no, that came out great.
Yeah, I was excited.
I followed along that path and did some screen printing earlier this week. I guess I could show that to you.
Let's bully it to the camera.
There it is.
That looks like a suspiciously similar design.
Suspiciously for sure. Yeah, I just got to finish with the ironing, and then it should be all set to go.
Is there a setting that it needs to be on when you iron it?
It says iron just match your material, so you can look up if your t-shirt's cotton, use the cotton setting.
Gotcha.
Gina, do you have a?
Just my candle holder, but this one is so much more robust than the last one.
Yeah.
I'm making it as a friend for a friend who has a birthday, and I'll put a candle and some battery operated lights, and it'll be like a mixed media kind of thing. So eventually there will be holes so that you can see the light of the candle through the I am probably going to do it with a plasma cutter. So if you look on the inside, there are shapes. There's a star and a heart.
That's what that was for.
And
that's sweet.
The peace sign and a little squirrely.
Yeah, sounds waiting.
So it's a bit of a process. But I'm also just gonna keep working with it and see what happens. And it might turn out completely different.
Yeah.
Open mind. It's important to keep an open mind when you're creating.
For sure.
No judgments. Yeah. So so if I did a heart here,
They were there. I'm not sure if they're in the window.
Okay. Should just show up here, right?
I think, yeah, I just saw a notification.
That's how I did the last cutouts. Do you remember the last one? Yeah, so I just
there
had
it
it
is.
upright,
Right
and
there.
the sparks aren't even doing
Jordan.
anything.
Welcome. Does anyone online have a show and tell item?
Oh no.
Not really cut it out, but only have
Nothing?
like certain bits.
I have like a drawing of what I want to make, but I haven't been able to learn how to do everything I need. Let's see. Okay, I don't know if you can see it.
Hey!
Yeah. Oh,
look at
cool.
that.
Wow.
So, I mean, this is an idea, so we'll see if it actually works, but I want to find a really nice piece of wood, and then I think I need to learn more metal shop skills. I want to make these legs that are kind of like mangrove roots, but I need to figure out how to bend it, and I messaged, I think it was Chris, last week, and he said it's doable, so just got to get the materials and get another badge and then start it.
Yeah.
Do you know what metal you're going to use for the legs?
I have no idea. Yeah, I'm not sure what would work best or anything. It's kind of just a shot in the dark at this point, but
Great.
do you have recommendations?
What? Nope, never done that. But
Yeah.
I'm interested to hear your experience. I can't wait to see it.
Thanks. I think maybe it'll be one of those things where I might have to make more than one to get what I want, but it's okay.
Cool. Yeah, I know we started talking a little bit about bending tube metal. I think comes with a set of challenges because you need to keep it from crimping or kinking up. But yeah, no, that we can find some resources to help with that. Any other online show and tellers? Nobody biting? In that case, we can move on to our freaking laser beams, and I can log out of JR Logan's email. Thank you, JR. So this week we are talking about lasers and vector design, which is everyone on Zoom able to see? Might just, no, I need to screen share. So vectors are a type of data for, oh, that's exciting. I need to share my screen. Vectors are just descriptions of shapes that computers can understand, which, as you might imagine, are extremely useful for all kinds of things, including laser cutting, which is the application we're going to talk about today, but we will also be talking about, there we go, vectors being used for when we get into CNC later on. If anyone started going down the water jet rabbit hole, that's all vector files that you're using to do water jet patterns. So vectors, shapes understood by computers, geometry in computer language, which can be made visible in lots of cool ways. So today, vector graphics, laser engraving and cutting. So there's, you can cut things out with a laser, certain materials, and you can engrave shapes or designs or whatever you want on materials. Lasers just remove material. And we'll talk about, yeah, the process for doing a laser project, some advanced design ideas, and some laser project ideas that you can try out this week. I have for 2 years been one of MakeHaven's laser facilitators, so I will encourage you all to make appointments with me or one of the other laser facilitators. My hours are Wednesdays, but of course, whenever works for you, I'll also be here for my office hours Sunday. And there's a couple other laser facilitators who can get you checked off and shooting frickin' laser beams very soon. But first, so vector graphics, this is kind of cool.
Pac-Man just wouldn't be the same without its colorful ghosts and the familiar yellow protagonist. Pixels haven't always been the only way. In the early days of the arcade, there were two principal paradigms for rendering an image on the screen: raster and vector. Raster comes from the Latin word rastrum, meaning rake, and today is the more familiar method of drawing on screen. The electron beam rapidly sweeps every line of the display in sequence, forming a grid. And line by line, a picture is assembled. Vector graphics directly manipulate the electron beam to form their images, in a similar manner to an oscilloscope. Indeed, very early games like Tennis for Two used an oscilloscope display. The most famous vector arcade title is Asteroids. And while its graphics might be sparse, the perfectly smooth polygons do boast a certain charm. Compare the appearance of two similar games using each of these methods. The smooth vector lines of Space War versus the blockier pixels of Star Cruiser. Vector graphics are cleaner, but less versatile. While raster images can't reproduce smooth lines, their ability to render more complex scenes and filled shapes help to secure the pixel's dominance.
So vectors and rasters in comparison, these are kind of the two formats that you will come across talking about images on a computer. So vector files are just, as I said, descriptions of shapes. So just geometry, coordinates, mathy stuff. And so the common formats, most common by far is SVG. So that's what Inkscape talks. It's an open format. It's pretty much any graphic you see on the internet is an SVG, probably, if it's some kind of interactive movie web interface thing. DXF is one that comes up for a lot of CAD, computer-aided design programs. AI is Adobe Illustrator, which is the Adobe equivalent of Inkscape, but it's proprietary software. PDFs can have vector files contained within them. HTML and XML are also capsule file formats that can have vector files in them. Rasters, on the other hand, are just, there's no math, it's just a big grid, and it's just a list of numbers saying what each color of each pixel in that grid is, and that's what makes the picture. So the numbers, and they're in hexadecimal, so there's 16 places, base 16. So the numbers and letters are just the number matching the color of that pixel. And bitmap is another term for a raster image, is a bitmap, because it's just mapping each of these bits. Or JPEG is really common, PNG, RAW, GIF, TIFF. So most, if you take a picture with a camera, that is going to be a raster. Vectors are not pictures taken with a camera. Vectors are math that the computer makes, or you use a tool like Inkscape on the computer to make. So it's kind of drawing, not so much a kind of image represented from reality. So there's a bunch of different programs. We're mostly going to be using Inkscape. I'm talking about Inkscape, but Adobe Illustrator is kind of the industry standard for graphic design. Sketch, CorelDRAW, I have not used actually any of them. Inkscape I have used by far the most. It's super capable and versatile, and you cannot go wrong learning it, or what we will be doing. So math descriptions, as I said, of shapes are useful for screens. So just displaying graphics on a computer, or for the lasers that we're going to be talking about, or final cutters, CNC machines. And they're useful for computer graphics because it's really easy to do live, like, animations. So on a web page, you can click a button and something changes about the page, things move around. That's really easy to do when it's just, the graphics are just mathematical descriptions of graphics. It's hard to do when they're pixels. So that's a big part of adoption of vector graphics. So when you start looking at Inkscape, as you will do if you get the laser badge this week, Inkscape talks about paths as kind of the fundamental vector shape. So a vector, as I said, is just coordinates and math that describe a line. Inkscape also has a bunch of different tools that can make circles and squares and rectangles, text, but fundamentally, only paths are actually vectors, which becomes important when you start using the laser, because the lasers only speak vector. They only speak path. They don't speak any of the other stuff that Inkscape can do. So the object to path tool will be your friend if you start doing lasering. Oh, and I should have said at the beginning, this week, as with every week, absolutely, if you have any questions, feel free to pipe up. Internet people, I don't really have a way to view the chat. Well, I guess I do. So feel free to unmute and just pipe up if you have any questions or have any knowledge that I am getting wrong or overlooking about any of this. So as I said, vectors make it easy to do math, and they are math, and they make it easy, therefore, to do animations and change graphics. So that makes it so they're totally scalable. So if you have, think about like, if you have a JPEG picture of your family member that you want to blow up to turn into a portrait to hang on the wall, but it was taken on a Nokia phone from 2003 and it's about 27 pixels wide. And when you blow it up to put it on the wall, those 27 pixels do not make a very clear picture. That is not the case with vectors. Vectors, you can make them as big as you need them. And because it's just descriptions of shapes, those shapes can get as big as you need or as small as you need without losing detail.
What are they doing in that picture?
It looks like mass. I am not 100% sure.
Is that not like final related?
Yeah.
I was wondering, like,
So
what's the cover on it? But that's all right.
it might be, so I think it's a printing process. So it looks like they have a banner that they printed. But yeah, I'm not sure if that was copying the design from another, that could be it, copying the design from a smaller version of the banner and blowing it up. If you have a design, we'll talk about this, and learning Inkscape, a big part of what people want to do a lot of the time is take raster images and turn them into vectors. Inkscape has tools to do that. They don't always work super well, but you can play around with them, and the simpler the design is, the simpler the raster you want to turn into a vector is, the better it'll work. But if you had, a black and white design like this, it would be pretty easy to take a picture of it, turn it into a vector, blow it up to be as big as a banner that you need without losing a lot of clarity. So fonts are the #1 vector object that you are interacting with on a computer. So when you make a Word document and you type something, you can scale it up as much as you want, and the letters are all going to stay readable because they are vectors. So Boolean operations are one type of operation that you can do with vectors. So these are examples of Boolean operations that when you start messing with Inkscape, you will be able to do. So that's just glomming shapes together, doing unions of shapes, or taking parts of shapes that overlap with each other, or taking parts of shapes that only that don't overlap with each other. And that is all things that you will do when you start using the laser. So lasers, light amplification by stimulated emission radiation. I'm going to be 100% honest. I don't know a lot about how lasers work physically. They are basically tubes that produce lots and lots of very concentrated light energy. And in the lasers that we have downstairs at MakeHaven, or industrial lasers, there's lasers that are powerful enough to cut sheet metal. There's a big tube in the back, and that is what's producing the laser beam. It gets shined out onto a mirror that reflects it onto another mirror, and then it gets reflected through a lens that focuses it onto the surface, the material that you're going to be cutting. So part of using the laser is focusing that laser onto your material to get the best cut. Because like when you take a picture without focusing your camera, everything's blurry. If everything is blurry, if the laser beam is blurry when it hits your material, it's not going to cut very well. It's going to have scattered energy. And this is super important. You're vaporizing the material when you're laser cutting. So if you stick something toxic in the laser and start vaporizing it, you don't want to breathe that. It's bad for you. It's bad for the person next to you. The big one, I will say it now, and if I'm badging you on the laser, I will say it many more times. Vinyl does not go on the laser. That's the most common material that it's typically plastic sheeting or PVC, just a very common plastic. That is very bad to cut on a laser.
Do you have a vinyl cutter?
We do have a vinyl cutter, yeah, so that's why we have a dedicated machine for cutting vinyl, because it's very useful stuff. And a lot of this, your Inkscape knowledge will transfer to the vinyl cutter. So for making designs, Inkscape can be really valuable for that as well. And not dissipating energy faster than it is added is another crucial property of a material that makes it laserable. So metals are really, really good at transferring heat, and so they're much harder to laser. They just absorb all the energy that's going into them. Wood, on the other hand, does not. It builds up energy very locally and just burns very quickly. Raster and vector. So this gets slightly confusing. So we just talked about, you now know the difference between rasters and vectors as types of image files on a computer. When you start using the laser, the words raster and vector also come up. They are referring to the two kind of modes that the laser can operate in. So with raster, you're telling the laser to rake back and forth over a design that you have, over a shape that is actually a vector on the computer still, but in raster mode, the laser just goes back and forth and typically engraves the whole area, just shoots lasers at the whole area that is taken up by that shape. And in vector mode, it's just following the line that your shape makes. So if you have 2019 Chan, the ornament with the outline of, I think, the state of Michigan. Someone correct me if I'm wrong. The outline is a vector operation on the laser. So the laser just followed the state of Michigan's outline all around, and then it had, actually it does it in the reverse order typically, but 2019 Chan would have been rastered, so just the laser goes back and forth, engraves everything that is 2019 Chan down based on the power settings that you put in for the laser. So choosing laser settings it's a little bit of a guess and check situation. So when you're doing a project on the laser, you want to, if you need a really specific result, like you need to engrave down a certain amount and you need it to be exactly engraved 0.025 inches, you're going to need to play around with changing your settings. But the three kind of settings that you're looking at are power. So as a percentage of the maximum laser energy that the tube can put out. Speed, which is how fast the head with the mirror and the lens that actually directs your laser onto the material, how fast that's moving. And PPI, pulses per inch. So the laser is actually pulsing a certain number of times for every inch that it travels. And so you set that number. Typically, I think it's anywhere from like 100 to 1,000 will be used for different types of material. And as you do more lasering, you will get a better sense of how you want to tweak these settings to get different effects that you're looking for. But there is a great cheat sheet on MakeHaven's website and hanging right next to laser that you'll be able to look at and say, I have a piece of cardboard, I want to do this to it. These are the settings I should start with. And most of the time that will work well enough for starting out. The thicker your material is, it'll also sometimes need to be cut in multiple passes. So you can only push this power up so much before you're running the risk of starting a fire, which is always a risk with using a laser. And so sometimes it's better to just run the cut multiple times to get all the way through the thickness of your material. The lasers downstairs, I urge everyone to go outside and look at the exhaust tube for the lasers. It's kind of fun. It's you can see the lasers in the space, and there's tubing going outside, and out on the side of the building it goes up like 5, 6, 7 stories, however tall the building is, to the roof, where it lets all the smoke that is produced by whatever you're lasering out into the sky, where hopefully it is not poisoning birds flying by. And it's not poisoning us who are in the space. So that's the most crucial thing. And you do need to remember to turn on the blower every time you start a laser job. when you're watching the laser cutting, you'll see flames coming up that are the smoke itself catching fire. That's totally fine. If you see any fire on your material that keeps burning, that's when you grab the fire blanket that hangs on the front of the laser, open the little laser, just throw the blanket on top of it. That will hopefully put out the fire. If it doesn't, there is a fire extinguisher hanging near the lasers. To my knowledge, it has never needed to be used. I have never needed to use the fire blanket. If you stick to the suggested settings, you should be pretty safe. But you are always staying with the laser while you're cutting, just in case something goes awry.
I did hear that they often catch on fire.
Here, I would believe it because I have not seen it firsthand. Should not be an indication that it does not happen. But MakeHaven has not burned down, so
Yeah.
the fire blanket and the fire extinguisher should come in handy.
And so, to triage, to troubleshoot the fire, again, it would be, making more passes. And that has to do with your raster.
So the number of passes you could do, typically that's talking about when you're trying to cut something out.
Okay, so that's the vector.
Yeah, so
Going
that
all
would be
the
for
way
a
through the
vector
material.
operation. Yeah,
It's
and
not gonna catch on fire when it's raster, when it's engraving.
only because you're typically only removing a tiny bit of material
Okay,
off
so
the
it's
surface.
just the vector.
Yeah.
And so you could slow down the speed or choose to take more passes.
Yeah.
So
And
that's like a depth issue.
yeah, because all the laser is doing is vaporizing material. So if your settings, if you're having it move too fast or you're not using enough power or a combination of the two, it will not be removing enough material to get all the way through when you cut. You do, as I said, run the more risk of starting a fire if you just slow down and increase the power. So that's why using multiple passes, just running the job multiple times can be a good idea if you're trying to cut through something especially thick.
So it would run through the entire.
Yeah.
job. So if you had the vector and the raster programmed, would you separate it into like vector?
Yeah, and it makes
I'm
it
gonna run the vector again.
super easy to do that in the
Then I'm gonna do the raster.
software. Yeah. So typically, yeah, so that's usually what happens. If you're engraving, if we go back to 2019 Chan, if you're engraving that ornament, you're cutting that ornament, you would have the engraving pass. Typically, you have a lot more latitude if you're just making something decorative. You don't really care too much how deeply it engraves as long as it's visible and it looks good. So you'd probably just run that once, and then then the vector runs, and if it doesn't cut all the way through, then you can go back and just skip the engraving and just run that vector part again. Yeah, and that's just in the extension in Inkscape that sends stuff to the laser. You can just skip what you set for the raster.
Is that easy to, when you are creating the rasters and the vectors, when you create this file, I'm not sure I'm using my language for it, you send it to the machine, is it easy to distinguish between the two? It was still just as a raster.
Yeah, so what you're dealing with, this is the confusing part, is raster and vector on the laser are referring to two operations that the laser does. So raster scanning back and forth versus vector following a line. On your Inkscape file, it's all just
sense now.
paths. Once you're sending it to the laser, it's just shapes. So
Okay.
the way, and I don't want to get too deep in the weeds because when you get batched on the laser, you'll go over all this and learn and be able to look at how it works in Inkscape. But it uses colors of objects of paths in Inkscape. So you can set everything that's green is going to be vectored with these settings, and everything that's red is going to be rastered with these other settings.
It's like you're describing the Michigan thing where the shape of Michigan is vector, but the words are raster.
Yeah,
Okay.
yeah. So it would be by default, just out of habit, I would have made 2019 Tran red and with a red fill, and everything that's cut out would have been green lines. But that's just kind of my habit. Never use PVC. As I mentioned, chlorine is very bad for you and the laser. It actually corrodes the lead screws and the other metal parts inside.
So when you burn PVC, you make chlorine gas.
Yeah, yeah.
It's awful.
Polyvinyl chloride.
You know, from personal experience.
Well, yeah, when my sister-in-law's of hair dye got left on a hot stove,
Oh.
and we're like,
Oh,
oh, it's horrible. It's the
yikes.
worst smell. You'll immediately recognize it once you smell it once.
I hope you were not breathing that for long.
Yeah, we opened all the doors.
Yeah.
Yeah.
Well, avoid.
Who eats all the brain cells?
Yeah.
That's good.
Well. No PVC, no vinyl. But on the flip side, there are many materials you can happily use in the laser without losing brain cells. So we've got craft plywood is kind of the big one. That's what I've used the most for laser projects that I've done. There's some for sale in the store, MakeHaven stocks. 6mm craft plywood. But that is a great material for all kinds of stuff. Solid wood can also be good. It's just a little bit less homogeneous than plywood typically, so you'll need to play more with settings. Different species of wood will cut differently or engrave differently.
With less than a thickness of 6mm. Under the vector, under solid
Yeah. So that's about the thickness of your material. So as I said, you don't want to just jack your settings up to cut through. You can do multiple passes and it'll give you less risk of fire, but at a certain point I think the walls of the kerf, the cut that you've made, just absorb too much of the energy from the laser. You're just burning what you've already burned. And so it just won't keep cutting at about 6mm is kind of a rule of thumb. So like 1/4 inch plywood or wood is possible to cut, but is definitely going to need multiple passes. And beyond that, on our lasers, at least, I've never seen good results with wood specifically. Other acrylic, you can go thicker than that, I think.
Can I ask one more question
Mhm.
about the wood? So since we're allowed to put plywood, and plywood has glue, I assume that these wood pieces of solid wood that have been glued together would be safe to put in there.
Yeah, and I know don't believe any common wood glues contain vinyl as an ingredient. And it's a small enough quantity in the glue joint that not sure I would be worried about it anyway. Yeah. Are you asking about like if you engraved on a cutting board that was glued together strips or something like that?
Actually, that's good. But
Yeah.
I've got these pieces of hardwood, whatever, it doesn't matter at all. Wood grain. And they're thicker, but I could thin them out using the jigsaw, right, to cut sort of like a sandwich and make them thinner.
Yeah, to make pieces that you could use on the laser.
Yeah.
Yeah.
Use on the laser.
Yeah, I would probably for that I would use the bandsaw. Would
That's
be
what I
my
meant.
first choice. Yeah, yeah.
I said jigsaw, that's what I meant, the bandsaw.
Bandsaw is good for that. Bandsaw, and then if you have the drum sander badge, that will give you a nice smooth surface after you resaw on the bandsaw.
And some of the
Welcome back, Larissa. Acrylic, Raster's like a dream, Vector's like a dream. It is the best plastic to use on lasers. If you see, there's a lot of scraps in the laser area downstairs. If you see plastic down there, 90% of the time it's acrylic. It's by far the most common just because it works the best, pretty much. It doesn't really like to melt. So polycarbonate, very bad idea. Generally not gonna make toxic gas, but doesn't work very well. Delrin works really well. Leather actually works really well. So like organic materials generally burn nicely.
It smells good.
I have never actually lasered leather myself. I've heard it smells good if you like the smell of burnt animal flesh, which we can leave aside for the moment. Fabric actually works really well, depending on the type of fabric, but generally, like synthetic fabrics are actually self-healing, or because the fibers will melt together at the edges, so they won't fray after you cut them on a laser, which is actually a plus compared to cutting with scissors. Glass, you can totally engrave. You cannot really cut with a vector. And it used to be at MakeHaven, we had a rotary axis for the lasers, so you could stick a wine glass or a beer glass or whatever in there, and it could turn it and engrave on the glass. We don't have that anymore. It is sad.
That is sad.
It's
So do
probably on the wish list. Go vote for it on MakeHaven's website, and we may get one again.
So do you not need that to properly engrave on glass?
You generally do. You have a pretty, so because
like
you're
a glass
focusing, yeah, just because it's curved, you're going to lose focus. You know, you can focus on the top of the glass, but as soon as it moves away from where you focused, your engraving is going to get very poor quality.
Right.
So the rotary axis definitely will be a lot nicer to have for that. Paper is basically wood that's been ground up and mashed together, so it works great. But you do want to weigh it down when you're using the laser because of the exhaust. There's a lot of airflow, so it can make your paper flap around. Mat board is also good to use. Corrugated cardboard is a little bit mixed for engraving. I think you can engrave on it if you want, just with really low settings. But you can definitely score a lot of corrugated cardboard from the recycling bin at MakeHaven.
Mhm.
I have used that many times for all kinds of early prototypes. So for testing new settings, there are some testing patterns that people have made that can make it quick to just run something. You are limited in the numbers of settings you can do on the lasers downstairs. You have, I think, 6 or 8 colors that you can set to different settings. But as I said, kind of a trial and error process to figure out what settings are going to work best for what you're doing on the material you have. So engraving, raster, engrave an image by burning away all the material contained within that shape. It can take a while. So a minute per square inch. You do set the speed for the raster, but that just sets how fast the head zooms back and forth, and it actually most of the time it spends at either end. Oftentimes, if you're rastering something really narrow, it'll spend a lot of time just turning around at the other end, so it still adds up even for smaller shapes. It does make big things. If you want to engrave, the lasers downstairs have, I think, 24 by 32 inches of area that you could work on. If you wanted to engrave across that whole area, even if it was just little lines, it has to sweep back and forth across the whole area you want to engrave. You will be sitting there for several hours, as I have done before, engraving across most of the bed. And you can be strategic about laying things out. If you have a bunch of different stuff on the laser, sometimes you can fit all the stuff you need to engrave into one corner so that it only has to go back and forth over a little bit of area instead of going across a bunch of little things spread out across the bed. The raster settings, you can do, as I said, I think 8 different settings for a cut. So if you have an image with different colors, you can make each of those colors in the image set to a different setting, or you can do different raster settings for each of those colors. So you can get a pretty lifelike SpongeBob engraving
From the laser.
if you make different power and speed settings for each of SpongeBob's different colors. So it would have been slower and higher power for SpongeBob's shorts, and very slow, very high power for SpongeBob's shoes to get a lot of blackening, and then very light for all of the outline and the sponge hole shadowing. Does anyone know what the holes of a sponge are called? I feel like that should have a special name. So the false color map, this is all stuff that will be easier to see when you're lasering, but you can set up the colors of your file to kind of match the colors of the image, but you do need to use specific colors to be able to set those colors to settings on the laser. So vector, following line, almost always cuts. You totally can engrave with a vector. It's just going to be a very, very thin engraving. Like if you are trying trying to cut something, it doesn't cut all the way through, I guess you're technically just vector engraved. There's, as I said, geometry is all that vector graphics are. What you see is what you get is one form of vector or any kind of design program where when you're working in the program, you're working on your Word document, you type some stuff up, you change the font, you go to print it out, that's exactly what comes out of the printer, which makes it really easy. You don't have to take a class to learn to use Microsoft Word. Vector designs generally are not that. So when you're working in Inkscape, sending things to laser, there's many things that can go wrong and weird things that can happen. There's a lot of possibility of having things in your vector file that you can't see when you just look at it. So you may need to, or you generally do need to get used to doing some sleuthing through lists that tell you what objects you have in your file to figure out where a problem comes from. This is a great example. So the ellipses are actually fully present as objects. So if you sent it to the laser and you just wanted to laser engrave ellipses and you wanted to look like that, just engraved around the bear, the laser wouldn't do that because it doesn't recognize the operation. Clipping specifically is a big one in Inkscape. Objects that are clipped in Inkscape will still be visible to the laser because the paths are still there. So something to keep in mind. So designing vector files for using on the laser, you want everything to be in a single layer. You don't want, oh, I'm sorry, clipping. In that case, okay, so the bear, I'm sorry, the other way around, the bear is covering the ellipses. They are not clipped. So clipping actually does change the path so that the ellipse behind the bear just isn't there anymore. So you do want to clip, and that will make it so the laser can't recognize the parts that are clipped under another object. Whenever you're designing something, you want to keep in mind for SpongeBob can only have 8 different colors engraved, 8 different settings for the engraving. So that's something you need to think about when you're designing. Converting your text to paths is always necessary, as with any object. It needs to get converted to a path to be recognized by the lasers. And nodes, when you start using Inkscape, every path is made up of nodes. And the more nodes, the more garbage can get introduced. So trying to avoid extra nodes is important, which can sometimes be unavoidable, like when you're trying to convert a raster image into a vector file. Most of the time, there will just be a gazillion nodes that it makes that can make those vector files kind of hard to deal with. And avoiding double cuts, just is going to save time. If your cut settings are right, it should cut through just cutting it once. But that's something you can run into. The amount of time a vector cut takes is just a factor of how fast you tell it to go and how long your lines are. So cutting a bunch of lines in a small area, rastering in a small area is going to be a lot quicker than rastering in a big area. Vectoring in a small area, if you have a lot of lines very densely packed together, that's going to take a long time because the laser has to follow every one of those lines at the speed you tell it to. So that can, and the laser also, the head needs to accelerate and decelerate when it gets to a corner. So having a lot of sharp corners in your design can make it longer than if you vector along a 10-inch long straight line, that'll be done a lot quicker than vectoring along 10 inches of sharp corners. So using primarily with acrylic, but you can totally do it with wood or any other material. Using masking will help to get a good finish on your material. So the laser is making a lot of smoke. A lot of that smoke, especially with wood, you'll see just shows up as scorch marks around whatever you cut or engrave. So masking will help to reduce that smoke buildup. A lot of times with wood, if you want to have no smoke buildup, you can mask it, that'll work well, or oftentimes you're engraving on something that, like a cutting board, I would engrave before you do the final sanding of your cutting board, because the sanding is going to get rid of all that smoke schmutz that gets burned on.
So what is the material that you would use for the masking?
There's a lot of options. Nothing with vinyl. That's number one.
No question.
Masking tape can work
Oh,
well.
okay, so-
Painter's tape.
Yeah.
There is masking like material, I think specifically for, for vinyl, which I'm not sure it's super cool to steel to use for lasering. So I would generally, for wood, just count on sanding afterwards. But if you just need to engrave a tiny part of something you've already sanded, just using masking tape in that area can work. And acrylic a lot of times will come with masking on it already. And so like clear acrylic,
Just leave it in there.
yeah, so like clear acrylic, to avoid getting scratched up, will have masking on it. So you can just do all your lasering with that on and then peel it off to when you're ready to have the finished product. And any kind of cutting or engraving, but most often it shows up on cutting, the sides are actually going to be slanted, because as the laser goes down, it removes the most material from the top and then the least material from the bottom. So a little bit slanted, and that'll be the most exaggerated with thicker material that you cut. So that's talking about the sides of the kerf. So kerf is a word that comes up a lot in woodworking or metalworking or laser cutting. Whenever you're cutting material, even on the laser, it's a really, really, really small kerf, but you're still just removing material. So whatever material you remove, that area is called the kerf. You're going to need to account for kerf whenever you're making like a box, there's tools that we'll talk about that can just generate boxes like this for you. You just put in settings, make the dimensions of the box you want, and it'll spit out a design. But you also need to tell it what kerf you expect to have for lasering this gluon on your laser cutter. You expect to lose 0.08 millimeters of material on either side of the line that the laser is following. So it will change its design, resize things very slightly to account for that material that's going to go away, so that you still have tight fitting joints.
Adam, how would you know how would you know that number?
It's something that you can do actually. So the #1 box making tool that I recommend has a file that you can just run on the laser with a bunch of different kerf settings, and then you can take it and try fitting the pieces together and see which pieces fit well. And the ones with the fit that you like, you can take that kerf setting and use that for whatever boxes you're making.
So there's a lot of trial and error with this.
There is a fair bit of trial and error in that. So generally for the same settings on the same material, you should be good to, when you try cutting this kind of plywood, you do that test once, you should be able to use those same kerf settings when you do it again, as long as your focus is consistent. But that is something that you do need to keep in mind when you're making things that fit together.
Can you chill the hair?
Yeah, do you guys
You're
want-
chilly too?
Oh,
Yeah.
yeah.
Oh, I'm sorry. Should we just turn it off?
That works for me.
Thank you. It was nice to get some hair.
I'm talking, I'm exercising, breaking a sweat. So the laser process, you have a design. Even if you get something somewhere else, you find an SVG file on the internet that you really like, you want to laser it, you're going to need to bring it into Inkscape. You're going to need to mess with your settings. So the big ones are, it's actually 0.02 pixels or less. Your line path stroke width needs to be, and the colors need to be set up for your file for the cut settings. And all objects need to be paths, and you can use the outline view in Inkscape to make it easier to look at stuff after you've done all that, because making your lines 0.02 pixels wide makes them not possible to see on a computer monitor. Then you export, you do all your settings for the laser, and then you prep the laser itself. You set the origin, tell the laser where the top left corner of your page in Inkscape is. That's your origin. You set the Z height to focus the laser. You clean the lens of the laser, and you verify that what you're using is going to be laser safe, i.e. is not vinyl, mostly. And last, you turn on the fan every time you use the laser, and then you press the green go button, and you stay within spitting distance of the lasers. I think the round table in the main room is as far away as you can go. Because if something catches fire, you need to be right there to deal with it. So the printing extension, everything is a little bit, feels like it came straight out of Windows 95, but it still works. We love it. Works great. So you're always going to set your, based on the colors, you can set each of your settings, and you're going to set whether it's raster, scanning back and forth, or vector, following a line, or rastering and vectoring, which I've never done before, but could be useful in some circumstances. This slider always needs to be set to 5. If it gets set to something else, it actually changes the dimensions of your lasering. It stretches it out and makes rastering lines further apart, which doesn't make a very good design. Yeah, and you will, this is a weird dialog box. You will get to know it very well once you start doing laser things. So making designs for the laser, if you're cutting something into a laser, if you're using laser to cut out like letters, you need to think about what parts are going to be held in the material. So a lot of times, like A will have the center of the A. If you just cut out an A, your A is gonna not have a middle hole anymore. It's just gonna be a solid triangle with 2 legs. And so like this is an example of a font where it adds tabs that hold the pieces that would fall, because it was used as a piece of material to stencil a design. So those are islands that would fall out if everything just got cut out. And that's true for the laser. That's also true on the water jet. It's true for cutting things on a CNC. They all have this consideration of parts that are loose after you cut them need to be dealt with. So the laser doesn't have like dedicated tools for making tabs. The WaterJet software does have dedicated tools for generating those tabs. CNC programs also, if anyone's badged on the Shipoko, there's tab tools in that software.
So you're responsible to make sure the tabs included. Like when you look at your design, it's like on my tab here, one tab here.
Yeah, so it's more important. It's most important on CNCs where you're just moving a bit through the material, and if you cut something out, suddenly that's loose and it can get caught between the bit and the rest of your material, which can break your bit or slash and gum up the part that you just cut out. So that's really important. On the laser, it's more about not losing pieces. So like you're trying to cut a stencil, you want to keep the middle of the A there, so you need to use a tab to hold the A hole there. Or if you're cutting out really small pieces, the lasers have honeycombing across the bits. So there's lots of places where if you're trying to cut out really small things, they would just fall through and get lost. So if you're trying to keep small pieces, you need to use tabs. Making patterns with positive and negative space, totally doable on the laser. Cutting things out, leaving them in some areas, removing them in other areas. Does anybody have designs that they're thinking about lasering, or any of these appealing as projects? This is kind of a cool application of lasers, so like making stencils, or making designs where you can have repeating patterns that you can cut out and really easily make. Any ideas for projects?
Or positive, negative, right? So
Yeah.
if I wanted to do, like, I have an image of a male and a female. Do they both have to be identical? But if I wanted to create cut out a piece of metal to do that, could I use this to do that? Or does it has to be rastered?
So cutting metal, you won't be able to do on the laser.
But so if I had like a wood block,
Mm-hmm.
could I do this on a wood block?
Yeah, absolutely. So talked about vector graphics, went over the crash course in lasering, which you will get to review when you get badged on a laser, and watch the video and take the quiz. We talked about what a preview of that process, what the laser process at MakeHaven is, and talked a little bit about design considerations for making stuff with lasers. We can talk about some project ideas.
Yeah, I like those maps.
Yeah, so that's actually, I will try to pull up a picture. That's most of what I've done for big projects on the lasers. I've made topographic maps, layering up
So cool.
different cutout pieces.
Did you design them yourself?
I did, yeah, and which was the vast majority of the time was setting all that up in the GIS software, and then taking it from the GIS software, which the mapping software, everything's vectors, so it's easy to move all of that into Inkscape, but then making the design something that you can cut out on a laser takes a lot of editing and weeding through. So that's true of a lot of kind of laser projects that you'll do if you're trying to bring another kind of vector data in to use it on the laser. You're always going to need to go through and clean it up and edit it to make it usable. We talked a little bit about the boxes. So boxes.py is kind of the go-to for that, and you can make stuff that has like enclosures tabbed together or jointed together with finger joints is the most common one that you'll see, and then just engraving on objects, anything wood you can engrave on. Generally plastic you can engrave on, but if you find a random plastic object, probably don't try to engrave on it unless you're certain that it doesn't contain vinyl. Looking at MakerCase or festi.info, those are both super cool. MakerCase has a bunch of different kind of basic box types that you can go in and edit. You can make your box be 6 inches and 2 inches tall and 4 inches deep, and you tell it what material you're going to be making it out of. You can make it have however many dividers you want. If you want very, very tiny dividers. It'll do that
Feel
for
like
you.
a lollipop in each one.
Yeah, yeah, yeah. Kind
This
of
is
a.
what Kaylin wanted to do.
Yeah.
Right? He was trying to make it
It's
out,
like the
he
wood
couldn't
version
make it
of-
out of
yeah.
metal.
I mean, can't do it out of metal on the laser, but you could design it here and then take your design and do it on the water jet to make it out of metal.
Oh,
This will also definitely work for that. Yeah, so this is just, this tool just generates an SVG that has, so I could do that. So it just makes all the lines that you'll be able to take to the laser, go through, cut it all out, and it should fit together. But this is where we were talking about Kerf earlier. This is where you need to be compensating for that kerf to be able to make, yeah, so kerf
Does it
and
give you
corner
any
compensation.
kind of idea about how much space to leave for that curve?
So this is where, yeah, so you'd need to do a little bit of experimenting. The other tool that's good for this is sd.info. Boxes.py, and this just has, I don't know, I like MakerCase because it's like clean and straightforward and has a cool 3D design, but boxes.py just has like a gazillion random things that you can generate, and it does the same thing where you can take, you want an angled box and you have this whole list of settings that you can change to generate the angled box of your dreams.
That's
That
amazing.
I love how this just exists.
I know, right?
it's out there, free on the internet.
So
The
there's
information
no reason
super-
why we shouldn't have this done by next week.
There is no,
Set
there,
my
Maybe
expectations.
like 10 of them.
You are-
I'm just kidding.
you are staring at a laser facilitator. He is before you. He will badge you. You will be producing as many boxes.py as you can dream of.
And are those just the burn marks?
Yeah, so these are all cut out of plywood, so the edges just
It's
get
got
burned.
style to it.
Yeah.
It definitely
right?
definitely is an aesthetic that you can see. This is a very makery aesthetic, I would say. The any maker space that's worth its salt will have many boxes.py made out of plywood with their nice singed edges hanging around. Yeah, and there's lots of examples, this kind of thing. What's that?
Pretty.
Yeah, no, it's a good look. There's lots of pieces like that that people have made. They're just by the lasers that you can look at for ideas. Yeah, so trays, shelves, wall-mounted stuff, tool holders, lots of options. More ideas. Making your own maker's mark is a fun Inkscape project. You
Like
can
the not like drink.
not the whiz. I mean, if you really identify with Maker's Mark, you could use their logo as your Maker's Mark, but you can make your name with a fancy design that you can then engrave on all the bandsaw boxes you make,
Yeah.
or what have you, as long as you're not really into making boxes out of PVC. It should be fine. So playing around with converting bitmaps, JPEGs, PNGs to vectors can be cool. If you take a picture of someone, you can mess around with it in Inkscape with those tools, and then you'll be able to engrave or cut out their picture without a fair bit of careful design work. They can look pretty disturbing, I have found, when you just take someone and try to engrave them in engraved and not engraved. It can be a little jarring. But yeah, just playing around with Inkscape and coming up with cool designs. Using, yeah, so if you want to make your person that you have a picture of that you want to engrave less jarring, you can use multiple colors to dial in your settings. And that is it for lasering. That is the beginning. That is it for the first toe in the vast ocean of lasering, I should say. Any project ideas? People seem interested. Anybody online with a
Box.
Yeah.
something here?
Boxes.
I will.
Make a
Make a
box.io.
I made a couple of things last year for a science Christmas thing, but I have pictures of it, but I don't know if I can share my screen.
I'm really having trouble understanding you. Sorry.
Oh, I'm on the train. I'm on my way home from work. Sorry.
That's okay.
Can you hear me now?
Yeah, that's a little better.
I'm like putting my microphone in my mouth.
That does.
I made a couple of Christmas decoration things for a science department Secret Santa that took me forever, and I have pictures of it if I can share my screen.
Yeah. Do I have to give you permission? Go ahead and try.
No, it says you have to give me permission.
And it is not showing me a prompt to do that, and I am not a super savvy Zoom user. Do you want to drop them in the?
Yes. Oh, well, yeah. Sorry. Let's see if I can find it. I can always show it next week too. Oh, wait. Hold on. Sorry. Bad connection.
Yeah. Just go ahead and send them to this. Oh, and I see your message, makeabox.io. I have not come across that one before.
That one is actually my daughter's name in cursive, and then I mirrored it and then connected all the letters to make a Christmas ornament. But I forgot I did that. I was addicted to this last year.
Oh, nice. Awesome. That's cool.
Wait, I love what I did last year. I have to find it because I don't think I'll ever do it again. It took so long.
That is, yeah, as I was saying about the map projects I've done, designing for this stuff can be very time consuming whenever you're doing vector design. And of course, as with any digital skill or any skill, the more you do it, the faster you go. There is a learning curve. But also you can get awesome results. So don't let that intimidate you out of trying.
And it should help you.
Okay. So did it show up in the chat yet?
Yes. Oh, that's
okay.
Awesome.
So the red is large intestine garland.
So funny.
And the blue is a uterus connected to make an ornament in a light blue acrylic.
Snowflakes. That's great.
So I just found the image online, and the hardest part was overlapping and connecting and then doing, vector versus raster. But I think it's hysterical. I love it.
That's awesome. More excellent project ideas.
Yeah.
Awesome. We did show and tell at the beginning again this week. And now we have had ending show and tell preview, Laser Week preview show and tell. Yeah, any other thoughts for?
When's a good time to come? Is there going to be a laser party?
A laser party.
Laser
That
party
sounds
is whenever you want to get badged on laser. I can,
Sunday, 12 p.m.
I will say, yeah, so Sunday, 12 p.m. will be my consistent office hours. I will put this on Slack as well, but I will be gone next weekend. So this Sunday I will be here, laser party time. The following weekend the following week I will not be here for class or my office hours.
So I need
But-
to get here this Sunday so I can have time to practice.
Sunday, 12 p.m. laser
Well,
party.
good.
12. I need to head out like 3:30 at the latest. But if that timing doesn't work for you, definitely send me a message and we can find another time during the week. Yeah. So my facilitator hours are Wednesday evening, so you can make an appointment with me then. Unfortunately, I think at least one other, there's like 3 or 4 laser facilitators now, and at least one of them is also Wednesday evening. So if that, but I think there's at least one other block you can get badged. So reach out. That up actually.
All right, so, do we need to sign up with you?
For Wednesday,
No, for Sunday.
for Sunday, I will be here. If you want to come, I might say I'll start noon. Whoever's here, we can go through, do the badging. 1 o'clock if more people come. If that works better for you, we can do the badging. But how about all on the Slack? I can do a poll and see
Okay.
if people want to sign up for a specific time to be here. That works for you.
All right, how long does it take to do the badge?
It's depending on how many people are there, it might be drawn out because I do want everybody to make a design and be able to cut it out. But it'll probably be an hour.
Okay, all right, would it be possible to have maybe 2 sessions?
Yeah, definitely.
I mean, I'll try to come, I run a pet sitting business, so Sunday is.
Okay, yeah.
So I'm gonna be like, cats, dog, food, come on, more dogs, more cats.
Yeah.
Class this week.
Yeah, of
Yeah.
course.
That was great.
Have a good evening.
That was great, and I
Laser
cannot wait to see
Shall begin.
your master project. Like,
Bye,
that is
Larissa.
gonna be, I love that